Hello everyone, my name is James Ryan, and I am here to teach you how the basics and eventually a few intermediates of coding. The basics of coding. And specifically, I'm going to be using processing, the language, and the environment to teach you guys how to make an abstract visualizer. But small steps first. Before we even get to that, I'm teaching you the basics of coding. So, last episode we made our first Hello World program. Just Hello World. We printed it and it outputted to the screen. You can still see it below. It says Hello World. Now we're gonna go back a step. We're gonna get rid of this Hello World for a moment, and we're gonna talk about this episode variables. And I'm not sure if I'll get into the specifics of strings and integers yet, but I will talk about variables. Yeah, I'll go into strings and integers. So let me tell you, okay? Let's create a new, because I probably have to in order to even create a variable. So let's create a new variable called a. Okay, so to do that, you write int a and then write equals. Now, before we get up this far, and then I'm going to write equals 5 and then semicolon. Now, let's take a look at what I've just done, okay? Int a equals 5 semicolon. What have I just done? Let's go through it. The first thing I wrote, int, is a type. What is a type? Well, each variable can be different variables can be different types of variables and can store different types of data. Now, the variable I've chosen here, int, is short for integer. And if you know that, what that means in maths, an integer is basically just means a whole number. So it's 0 or 1 or 2 or 10 or even negative numbers. So even -5, -10, -15. But it's not a fraction, it's not a decimal, it's not irrational or anything like that. It's a whole number. It's just one or more digits, but no points, no decimal points. Nothing too fancy. That's what an integer is. The next thing is the name. So this is the variable name I've chosen, a. It's not very fancy, it's not very descriptive. You're probably going to want as descriptive names for your variables and your functions as possible. Now, some good rules for naming your variables is name them what they are. Name them what they store. If you're using a variable to keep track of a score in a video game or something, call it score. If you're using a variable to keep track of the x and y coordinates of an object, call them x and y, or call them coord x and coord y. Something descriptive that tells you what it is. Something important to note when you're naming things in programming, a common convention and a very good one to use, because a lot of things in programming can't include spaces, because spaces are interpreted as, whoa, we're doing a new thing now, we're not talking about the previous thing, by the compiler. If your name of what you call something has multiple words in it, you're going to have to figure out a way to express it in one word. And what programmers usually do is rewrite in something called camel case. You know what lowercase is? Lowercase is this. Hello. And uppercase is hello with all big caps. Now normally you write in sentence case, which means you start off with a capital letter, you write the rest of the word in lowercase, then to make a new word, you press space, then you can start a new word in lower caps. It's all lower caps from then on, and then at the end there's a full stop. There you go. But we use in programming something called camel case. Camel case means you start off with a lowercase letter and you write the rest of the word in lowercase. And then whenever you start a new word after that, you begin with a capital letter and then go in lowercase. So that way you can stick the whole thing together. It's all nice and neat, but you can still tell the difference between different words. Hello there, world. So that's how naming conventions work. Now, the next thing is the equal sign. the equals. And the equals doesn't actually mean equals. It's not like algebra, it's not like maths. It's not like saying, well, a equals phi. It's kind of like that, but it kind of isn't. It's, I could say a equals 5, but and it does mean that from then on a equals 5, but it's not saying that it's equal. It's not a mathematical statement. What it's doing is it's setting the variable called a to be equal to 5. It's taking it and making it equal to 5 only at that particular point in the program. The reason variables are called variables, at least in programming, in maths they're called variables because you don't know what they are, so so it could be I don't know why they're called variables in maths actually. Are they called variables in maths? I think they're called something else in maths, but I like to call them variables in maths anyway. Probably because I associate maths and programming and science and all that together. But the variables in a computer program are called variables because they vary. They change over time. They vary. So you could just as easily later on write a equals 10. And then finally you put in a value. And a value is what the variable equals. So for integers, you'd put in an integer, but and so on and so on. And then finally, the semicolon, which says, hey, this is the end of the line, go on to the next one. So let's experiment, okay? Let's say int a equals 5. How do we use this int a? Well, you use this int a, let's use it using the only function we know how to use so far, the print function. What happens if we put print a? Now you may expect it'll print the letter A, but remember we just set A equal to 5, so what will it print? Let's press run and find out. As expected, it printed 5 down below. If you expected that, congratulations, you're starting to understand. Very good. Okay? Now, what if I go ahead and say, well, int a equals 5, and then I write a equals 10. Now, note that I didn't write int. That's because you only need to declare the type of the variable when you first declare it, when you first initialize it. When you initialize a variable like this, what you're doing is you're basically saying to the computer, hey, I want to make a variable, so go ahead and allocate some storage space in the program storage space for this variable and say, over here we're going to have a nice integer variable called a. Okay? That's what it says. That's what it's saying. And then go ahead and set that value equal to 5. Okay? But after we've gone ahead and created a space for the variable, we don't need to do that anymore. So we just go ahead and say a equals 10. And what a equals 10 basically says is, hey, you remember that place that I created and set aside for a? Yeah, you remember a? Yeah, go ahead and change that a to a 10 now. I don't want it being a 5 anymore. So that's all good. So if I write int a equals 5, and then I write a equals 10, what will print a return? The answer is, of course, 10, because while a starts off being 5, it then goes on to the next line and becomes 10, and then it gets printed. And when it's being printed, it's already been turned into a 10, which means that it'll print 10. Now, what if I go after print a and I write a equals 25? Will this affect it? Will this affect print a? No, it still prints out 10 because it starts off as 5, becomes 10, then when you print a, it prints out 10, then it becomes 25. If I stick another print a after a equals 25, then when I press run, I get 1025. Any guesses as to why?